the drain current, okay, for particular VGS, okay. So like this. So there is many things are there inside this. So here I cannot explain. And if I have some scope in future to deliver another talk, then I can discuss this in details, the gallium nitride HAMT. Okay. Otherwise, yeah, this is the short description actually. Okay, for gallium nitride based HAMT. Okay. So do you have any question here, gallium nitride HAMT? Okay. So I'll skip this part because I don't have time, that much of time, because I have office also. So this is the gate leakage mechanism of gallium nitride HAMT. Okay, so this is actually very important thing. Okay, gate leakage. Okay, I'll just describe in brief actually. So generally we know, right, the drain current, we know that horizontal current, right? Horizontal current means we have the drain current is flowing from drain to, sorry, this way, right? This is the drain current, okay? That we know. But there is some current, right, that can flow even here through this. Okay, that is called the gate current, IG. Okay, the current can flow also this direction. Okay, and this vertical current. Okay, that is the gate current actually. Right? This has different gate leakage mechanism to describe this IG actually. Okay, so there are few mechanism that I can show you. There is the follow the tunneling. There is a different gate leakage mechanism. Okay, so then there is a pull Frankel emission current, harmonic emission current, defective state tunneling current. Okay, and yeah, so this is the structure actually. So this is the reverse bias condition and the forward bias condition. Okay, so both this case VG is actually greater than VTH, but for this case the VG is negative. Okay, for this case VG is positive. Okay, so now the question comes that why VG is negative. If VG is negative, it should not be higher than threshold voltage. But in case of gallium nitride HAMT, unlike the MOSFET, in case of gallium nitride HAMT, the threshold voltage is actually negative. It could be around, typical value could be around -4 or -5 volt, like that. Okay. In case of MOSFET, VTH near about 1, you can say 0.5 or 1, like that. Okay. It's always positive. Okay. So in case of gallium nitride, it's negative. So that's why it's a reverse bias. We can classify it into reverse bias and forward bias. Okay. So you can see, right, the electron is moving from this direction, right? Okay, the vertical. Earlier it was this one, but now it's a vertical direction. Similarly, for electron is moving from semiconductor metal here. Okay, so this will contribute to harmonic emission and defective state, and this current reverse bias reverse bias region operation, the gate leakage current will have polarizer and full Frankel emission. Okay, yeah. So yeah, question. Any question here? Because if you want to make career in semiconductor, so suppose in future after BTech or MTech, if you want to do MTech, or if you after MTech if you want to go to semiconductor industry, right? So this leakage current you have to always think about it. It's a very serious issue, the gate leakage current, because this gate leakage current is actually unintentional current. Okay, we don't want this leakage current, right? We don't want this, but even you don't want this gate leakage current will be always present. Okay, it's something in nanoampere, something in nanoampere. Okay, like that, or sometimes it is in microampere if the device is not reliable. Okay, nanoampere or picoampere. Okay, so now nanoampere is very less current, right? Now in IC, if you have in one IC, okay, this IC chip, okay, IC chip, okay, IC chip, and inside the IC chip, millions of transistor or billions of transistor or even trillions of transistor inside this IC. Okay, okay. Now, if you add up all this, actually, this all this leakage current, right, in the nanoampere range, then what will happen? If there is a millions of transistor, that 10 to the power 6 into 10 to the power -9, then the current is high, right? That's a milliampere current. is significant amount of current that we don't want actually, but it is inside this device, right? So if we use mobile, right? If the leakage is very high, then what will happen? Then if we keep that mobile, okay, we don't use that mobile for 1 hour, and then before using that mobile, okay, before using that mobile, you have suppose so before using that mobile, you have suppose 90% battery, okay. So then you kept it, okay, and then you see that okay, my battery gone down actually to 30%, and that is because of the leakage current, because unnecessary power dissipation is coming here, okay, because of this leakage current, okay. So that's the very important thing, this phenomena or mechanism that always we need to study, we need to analyze in industry, okay. And yeah, and I will also give one example, another example. So this is the different leakage mechanism. I will not go in these details. Okay, the energy band diagram I have shown here. Okay. So now there is a basic NAND flash device. Okay. So NAND flash device means what? That I told you, right? NAND flash device basically that memory device, right? So that we actually use, right, in our pen drive or SSDs, right? Okay, it's not a HDD. Don't compare it with HDD. Okay, it's a SSD part. Okay, only SSD part, and SSD is actually based upon semiconductor. Okay, so if you compare the MOSFET structure, okay, and this NAND flash device structure, right? Okay, so you can see there is another gate here. There is another gate. Okay, in between, okay, and there is another insulator. So gate is floating here, right, in the insulator, okay. So we are introducing another gate. This gate is floating gate actually, and this is the gate where the electron is actually storing, okay. This is the electron is storing here, okay. The electron is coming from this, okay, here, okay. There's the electron is storing here. So this electron is actually responsible for storing your information, basically. Okay. So if you want to store, if you want to save one song, right, 5 MB song or 10 MB song, if you want to save. So let's explain first tunnel oxide. This insulator, okay. So this is the insulator. So this is called the tunnel oxide actually. So this insulator is actually the why we are introducing, because the electron is actually moving through the insulator. There is some electric field here. Okay, inside this there is the electric field, and then the electron is moving here. Okay, the electron through this insulator. Okay, and this insulator is blocking oxide because we don't want the electron move from this gate to this gate. Okay, we don't want this. Okay, that's why this insulator comes into the picture. This insulator is basically little bit thick. Okay, this Tox 1 and this is Tox 2. That is thickness I'm telling. Tox 2. Then this Tox 2, Tox 1. That is this one should be greater than Tox 2. Okay. So what will happen if we increase the thickness? The electric field will reduce. If the electric field reduce, very few electron move, okay, from this gate to this gate, okay. Most of the electron will remain here in this gate, floating gate. So we can, the electron will remain in the location, at their particular location, okay. It will not leaky, okay. So that's why this leakage current is actually very important term actually in the semiconductor industry, because here also the leakage will happen, right? The data, right? If you want to store the data, if you want to store the information, then there will be leakage in that way that your data can actually the information that you store, that information can be lost, okay, not in a 1 month or 2 months, you keep that data for 1 year or 2 year or 3 year. Okay, maybe there is a possibility that if the device is high leakage, is having high leakage, then there will be possibility that your information will be will be get away from your actual location. Okay, then you will find, okay, I don't have that file that I stored 3 years ago. Okay, so this is the basic NAND flash device structure. Okay, then I will just show in brief the NAND flash operation. Okay, there is a three kind of operation. Okay, one is program operation, another is erase operation, another is the read operation. So three. So first in that way will come the step by step erase, program, and then read. So what's the erase? Erase means we actually delete files. Okay, we actually delete files. That is the we can correlate with the erase. Okay, program means if we transfer some, let's say some movie or some file you want to transfer from your pen drive to your laptop, right? So basically you are programming your laptop in some location, in some particular location, right? That's the programming. Okay, and reading means suppose you are opening some file, PDF file, right? Yeah. So that way you can say that's the you are reading files actually. Okay, so basically this is the program operation. Okay, so storing files actually in the laptop, pen drive, memory card. Okay, so what's the operation actually? For program to do the program, you have to apply the gate at very high voltage, and then you have to apply channel potential equal to 0 volt. Okay, that would be intentional. Okay, intentionally we did it 0 volt so that the electric field across this will be very high. Okay, because this is a 20 volt high voltage and this is very low volt. Okay, the electric field will be high. Okay, then the electron that I already discussed, right? The electron will move from this way to this way. Okay, you can see the electron is moving from channel to floating gate. Okay, so that way we can see the program operation is happening. Okay, so if there is a erase here, okay, this y-axis is number of cell and the x-axis is threshold voltage. Okay, if there is a erase, then after programming, after giving 20 volt, the program will happen like this. Okay, this kind of histogram distribution. Okay, this is a cell distribution actually. Okay, so program is happening from negative to positive. It's moving from negative to positive. Okay, now same thing for erase, just other way around. It's just opposite. So here I am now applying VPG is equal to 0 volt. Okay, and the channel potential here is very high. So the now the direction of the electric field will be this. Okay, so what will happen? The electron will go here. Okay, from this. Okay, see this. Okay, so now this direction. Okay, you can see the electron is moving from floating gate to channel. Okay, so there will be no electron here. So means you are erasing. The same thing, the program, this is the distribution, cell distribution actually. Okay, so if it is programmed, then after applying this bias condition, so the distribution will come here. Okay, so for reading operation, same thing actually. I can say okay. So here, so there is a two thing program and erase. Okay, so reading operation is actually we have to decide whether the transistor is on or off. Okay, on or off. So basically, we are applying some period here to the gate. Okay, and the electron is here. Okay, so now the question will come, right? So I am programming. Suppose I am programming. Suppose some cell. Okay, now I don't see that electrons actually in the floating gate because it's not possible for us to see. Okay, now how do we decide that whether the cell is actually programmed or not? Okay, but or how do we decide the erase the cells, particular cells or particular transistor is actually erased or not? Okay, so that could be done by read operation actually. Okay, so we have VRead. Okay, that is VR. So this is the VR. Okay, so now suppose the distribution is here. Okay, if VR is less than VTH, okay, so in this case the VR is always less than VTH, okay, then it will be read as a binary 0. Okay, so we know that what is binary 0 and binary 1. Okay, so in that way our all the files, right, files, whatever the files, movie whatever, that will be stored in terms of binary ultimately, right? 1 GB, if you convert 1 GB means 1 GB. If you can convert, it will be converted in the binary value 0 1 1 0 like that, right? So ultimately we are storing in terms of binary. Okay, so VR less than VTH means it is reading as the cell is reading as a binary 0, and VR greater than VTH means the cell is reading as a binary 1. So in that way actually we read actually whether the particular files the binary value for this corresponding file is actually whether it is 1 or 0. Okay, so like that we read. And the next is the DR. So yeah, that part. Yeah, so DR is actually the data retention. Okay, so what is data retention? Okay, data retention means how can we retain the data actually. The okay, data retention is the ability to keep the data in the memory device for a long time. Okay, so suppose you have stored one movie, right? That is 1 GB movie in your, suppose in your laptop. Okay, in your laptop you have stored in the SSD. Okay, now you are not means you kept this 1 GB movie for suppose 5 years. Okay, or suppose 5 years. Okay, so what will happen, the information, right? The information what we store, there will be always leakage, right, inside the device, and because of the leakage current or different leakage mechanism, the information might get away from its actual location. Okay, okay, so if the DR is not, if the DR is very poor, means the reliability of the particular device is very poor, then there is a high chance, or there is a little bit chance that you will not see that file after 5 years. Okay, so that's the DR actually. So we have to take care of the data retention. So the data should be retained maybe some 3 years or 4 years or 5 years, that depending on the how much the company is giving the warranty period. Okay, the company always gives some warranty period. Okay, you 3 years warranty period I am giving, or 4 years warranty period is I am giving. Okay, so it means what, 3 years, at least 3 years you have that data. Okay, that's the warranty period. Okay, after that we don't know what will be that there, but at least 3 years you have that data. Okay, so that depends on the warranty period. Okay, so this is the 1 GB data that if the reliability, the device reliability is very poor, then maybe in 1 year the file will be gone. Okay, so yeah, so here we see the leakage. What are the leakage? That electron is stuck here. Okay, now electron can move. Okay, this way, this way, this way. But we don't want. We want to store their electron here. But electron is not. Some of the electron is moving away from this actual location. So we are losing the information here, right? So these are the different this gate. This is the memory structure actually. Gate insulator channel. Okay, so this is the electron that we are storing. Okay, so this is the well. Okay, so inside well we are storing. So now you can see the thermal emission leakage mechanism. Okay, the electron can move away. Okay, using trap to band tunneling, the electron can move this way. Okay, so we are losing electron, right? In this way, in this way. Okay, then also we can pull Frankel emission. Through pull Frankel emission, we can also the electron also can be move away from this actual location. So this is another mechanism, thermal emission and retrapping. Okay, so these are the various leakage mechanism. Okay, here are many leakage mechanisms are there, but this is the so that's why the leakage is very important. Okay, when we are dealing with drain current, okay, we have to deal with the leakage current also. Okay, and it's a very important thing in semiconductor. Okay, always you have to study that about how leakage current is there. Okay, you have to model it. Okay, so any question here in NAND flash device? Do you have any question?
No, you can proceed.
Okay, yeah, so last thing is the opportunity in the industry. So that is the important thing. Okay, so here, so if anyone, so you are from BTech, I think, BTech Electronics and Communication, right? Engineering. Okay,
Yes,
okay, so second year, third year, final year, right? I think.
yes, yes.
So studying electronics and communication, so there is a huge chance in semiconductor industry. Okay, so
Yeah, they have just started the means the second year has just done the devices and analog circuits.
okay,
Only that much.
okay, yeah. Yeah, so step by step, it's when you go third year, then some more subject will come, and finally also some even more subject will come. Okay, you can study that. Okay, so now I will just tell how can you go, how can you make the make career in the semiconductor industry. So we always tell okay that after BTech we can go IT and all software industry, but uh, it's a very now what is happening the semiconductor area is amplifying like anything, okay, because the main thing is the government is also taking interest on that actually. You can also I think you heard about that many the fab lab fabrication lab, okay, two three fabrication lab was already approved here, and one in Gujarat, two in Gujarat I think, and one is also Assam I think, okay. So this is just a starting point. Okay, up to many for many years, this will go like anything. This semiconductor industry, and if you go in semiconductor industry, and your starting salary maybe 10 or 12 lakh, right? Okay, but you have to make first. You have to build up the concept first. Okay, okay. How to make the concept? So first you have to that is also applicable for all case. Okay, that is good CGPA. That is the in general criteria, right? But you have to get a good score in GATE also, right? In EC paper, okay, in EC paper, and do MTech. Okay, I will suggest do MTech if you want to go in semiconductor industry. Okay, because MTech is very necessary nowadays. Okay, I don't know after 10 years or 15 years what will happen, but as present scenario, right, BTech they will not prefer. Okay, it's very difficult for BTech student to go into semiconductor industry. Sometimes you will know, right, you come to know okay that person is going into Samsung Semiconductor, okay, Samsung R&D, okay, but you ask him, okay, that BTech guy, you ask him that in which group or in which team he is working, then most probably there is high chance that they can be they might say okay I am not in core group, I'm in software group, okay, IT group, because in semiconductor industry also we need IT groups industry group, okay, or some other team also there which supports that means which supports different softwares even farmer, okay, this is not a core group. But if you want to go to move to core group, okay, where you have to deal with different IC chip, okay, device characterization, okay, IC characterization, designing, okay, then you must have to do the MTech or MS, okay, there is a MS, okay, that MS is actually it's an IIT actually. Some of the IITs, not some, many of the IITs providing this MS course, okay. MS is by research actually. MS is three years, okay, and MTech is 2 years, okay. So MTech you can do from even NIT or from private university also. Okay, it depends on your gate score obviously. Okay, if you have good gate score, if you get a better college. Okay, right. So now what are the different courses that you have to do in the MTech? Okay, so these are the courses, right? The VLSI design, microelectronics. Then sometimes you will see the combination of these both VLS and microelectronics. Okay, then integrated circuit system is also there. Okay, then new MTech is there. The MTech they have introduced in IIT Hyderabad. I think I'm not sure, but in IIT Hyderabad the new MTech course uh, they have introduced. There is semiconductor technology and chip design. These all are more or less similar. You can say that. Okay, some subject difference there, but more or less similar. You can go either of these things, or many other equivalent name is there. Okay, I am not going into that, but these are the main thing. Okay, the VLSI design, microelectronics, VLSI and microelectronics, integrated circuit system, semiconductor technology. Okay, and then these are the different semiconductor industry. Okay, so these are the USA based and Europe based company. Okay, okay, so these are few company. Okay, many more companies are there. I have not mentioned here, but many more companies there. So Intel we know, AMD we use, right? AMD Ryzen, that CPU we use. Okay, that NVIDIA we all know, right? The GPU. Okay, inside the laptop we have GPU, right? That supports the gaming graphics and all for gaming. Okay, then Western Digital or SanDisk, right? So my company. Okay, then Analog Device is another company. Okay, Micron is Micron is recruiting lot of freshers actually nowadays. Okay, so you can go there also. Samsung, we know. Okay, Global Foundry, then ST Microelectronics, Texas Instrument. Okay, all are the US and Europe based company. Okay, now some of the Indian companies also there. Okay, here I have given few names, but there's a TCS, HCL, Infosys, Wipro. So we actually know all these company on their software platform, right? Software IT platform, but they have also team, that VLSI team, or that team is there. Okay, in HCL also we have semiconductor area. Okay, this Infosys Wipro. So we can try. You can try also here, right? And if you come to Bangalore nowadays, since in India, more USA and Europe based company are investing here actually. Okay, so what is happening? Many startup companies are also there in Bangalore. At least in Bangalore, I don't know about other area, but in Bangalore I see many startup companies are there. Okay, maybe here the some yeah. So you can start your career, and then later on you can go by gaining some experience. Okay, you can go in this big company, but you can start here also. That is also good. Okay, semiconductor startup is there. Okay, so now these are the job profile. Okay, so these are the device profile, device modeling. Okay, these are the memory device engineer. Then ticket is also there, but I think I don't know whether you know or not. But ticket is technology cadet um, aided design actually. Okay, so this also a very important area of the ticket. So then, yeah, these are the device profiles. If you want to go semiconductor device, then these are the profile. Okay, semiconductor device profile. Then design profile. Okay, these may be a design profile. The analog circuit design, RF circuit design, digital design engineer. Okay, so these are the profiles, and many other profiles are there. So this is the main profile I am just showing. Okay, many other profiles there. Then the process. There is a fabrication. Okay, there is a fabrication process, integration engineer, yield engineer. All are there actually in India. Okay, in this company. Okay, in this company actually. Okay, so many profiles are there. Okay, so we can go. Okay, so very huge opportunity. Okay, literally I'm saying there is a very huge opportunity. Okay, so you have to just do a gate score. Okay, get your means MTech you do, then you will see the opportunity. Okay, as a freshers, I think you will get, if you have studied these subjects. Okay, be you have to be a in-depth concept. You should have very in-depth concept in these subjects actually. Semiconductor device physics. Okay, then I don't know, technology process fabrication, that is another subject, but it is optional. But you should have some basic knowledge in this case. Okay, but you should have very good knowledge in semiconductor device physics. Okay, what is MOSFET, how it is operating. Okay, you don't have to go to advanced level devices that I have showed here. Gallium nitride, NAND device. The interviewer will not ask this question. The interviewer will only ask from your basic devices: MOSFET, PN junction, BJT, N type, P type. Okay, so you should have basic concept. Okay, then analog circuit is very important subject. Very important subject. Okay, yeah, you should have in details concept. Okay, then electronics. Okay, digital electronics basically two types. One is clock level, another is transistor level. So
They
both
also have the digital system design and VLSI subject in their third year.
yeah. That is actually, I think that's a transistor level. That is integrated circuit design. Okay, yeah. So you should know this. Okay,
আমাদের একটা লেডি রয়েছে তোমার ডিপ্লোমাতে এডমিশন নেওয়া হয়েছে সালার সালোয়ার
and then it's a circuit theory. This circuit theory, and then signal system and control system. Okay, these are very important, very important subjects.
ইমেল ইমেল তোমার যে পাসওয়ার্ডটা সেটা
Okay, so with that, if you have any question, you can ask me. Okay. So this is the last thing. Okay. So you can connect with me. Okay, through my email or LinkedIn. Also, you can connect with me. I'm available in LinkedIn, so you can connect with me. Okay. So, have you do you have any question here about the industry? Because you have to go by this way actually. Okay, if you want to make your career in semiconductor industry and BTech, I'm literally saying nowadays BTech they prefer, but very less preference, very less for BTech. Okay, okay, some companies they prefer BTech, but very less opportunity. But if you do MTech, then there is a huge chance. Your chance will be go high. Okay.
Okay, I want to know what is the opportunity in RF circuit designing.
Yeah, RF circuit design. See, yeah, it's actually a difficult area. Actually, very difficult area. So there is RF circuit design courses there. Okay, in RF actually this RF circuit design profile is all are there in the Intel also there. Okay, NVIDIA is also there. Okay, NVIDIA, not in Western Digital, but not in NVIDIA. I think AMD, Intel, then Global Foundry, Samsung also I have that RF profile. Okay, this demand is low, little bit low as compared to analog circuit design engineer, but and also little bit different, difficult also. Okay, this subject, but you need to do course. Okay, you need to do course. For example, in IIT Madras, when I was there, one of the faculty he was specialized in RF circuit design. Okay, there is a subject was called RF circuit design or something. Okay, so that course you have to do. Okay, and you should have hands-on experience in RF circuit. Otherwise, they will not take. Okay, it's difficult. Because in MTech, when you in the project is there, right? In MTech, okay, 1 year project that is in second year, right? So that project you have to choose carefully when you are doing MTech. Okay, okay. So that project will actually will be will impact your career actually to get opportunity in the industry. If you are suppose if you are working in RF circuit design engineer, okay, you want to make your career, then you choose your project based upon the RX circuit. Then it will help you to get into that industry, particular industry. Okay, so yeah, if you have a hands-on experience is a project. Okay,
So, can you please suggest some projects that we as undergraduate students can do for semiconductor devices?
yeah, semiconductor device you can right now specific project I cannot say, but you can go with this project final year project, right? The analog circuit design. Okay, that you can go and do you you have cadence synopsis tool uh,
We are doing it in Tenor.
what
Tenor software, Tenor EDA.
okay EDA okay yeah it's okay any EDA tool if you have then it will be better. So using EDA tool you can select the project actually, so you can do the project actually. Okay, so in analog circuit design. Okay, so you have to talk with your faculty, okay, in your institute. Okay, so it depends on faculty also whether he is in that area or not. Okay, it
Okay,
depends.
sir. Okay, sir.
Okay, so also if you have ticket that is also good. If you have ticket tool, there is a tool is actually. So if you know that if you do some project based upon your ticket, then also you can at least mention in your resume, right? I know ticket, right? That will also help. Okay, if you mention in your resume, okay, I know analog circuit design, not in theory based. I have some practical knowledge because I have done the project in the final year. Okay, that also will help. Okay, or also you can go with the digital area, right? Digital design, that this one actually, digital integrated circuit. You can do the project. Okay,
Okay,
so
sir.
these are the
Thank you,
main
sir.
things. Mm. Yeah. Any other question?
I think there is no more question left.
Okay. Okay.
So I would like to. That was a very wonderful session, actually, which provided deep insight in the semiconductor industry
Yeah.
that is currently growing in India. So, as we have come to the end of the session, I would like to thank the speaker, that is Dr. Onkur Devnath, for sharing your valuable knowledge regarding the semiconductor industry and its future scope and the types of jobs that our students can get in the semiconductor industry, the way they can move towards it. I'm really thankful to you.
Yeah.
Uh,
Thank you very much. Yeah, it is my pleasure also to give this such technical uh, talk in Techno College of Engineering. Okay.
yeah, we will surely have more sessions like that in future.
Yeah,
I
yeah,
would like
yeah, sure.
I would like to thank the Techno Group also to sponsor the event, and I also would like to thank the organizing team for handling the technical part perfectly. Thank you. I think we can end the session right now.
Yeah, thank you, Dr. Yansha. Thank you very
Yeah,
much. Thank you, students, okay,
thanks.
for attending this
Hmm.
technical talk. Okay, thank you. We'll close then. Yeah,
Yes, yes, yes.
yeah.